Hey guys, here's some notes that, in case you missed them on Friday in class, we were just talking about inequalities in triangles. It was just a short one slide notes. We were looking at this triangle in class, and we made some observations first. First, we decided that it was an obtuse scalene triangle. We actually measured this angle, and it was an obtuse angle, 110 degrees in class. So it was an obtuse and it was scalene because all three sides are different sizes. Scalene is when we have three different sides, no equal sides in a triangle. Let's call it a scalene triangle. And since angle B is obtuse, and we knew that all three angles in the triangle add up to 180, we proved that in our last notes. That means the next observation we could make was that angle B is greater than angle A plus angle C together. If angle B is obtuse, that means it's more than 90. That means these two together are going to be less than 90. And you have to make sure they add up to 180 degrees. So if you take 180 and subtract out 110, you've only got 70 left for these two angles together. So angle B is going to be greater than A plus C put together. Now the question that I was asking the class was, is angle A bigger than angle C? And just by looking at it, it looks like it's bigger, but can we prove it? That was what we came up with, was can we prove it? Is there a way to show for sure that angle A is congruent to angle, or larger than angle C? And there actually is. There is a theorem called the opposite side angle theorem. And the theorem says this. You can pause it and write it down anytime you need to. If one side of a triangle is longer than another side, so if you look here, this BC is longer than AB is than 7, so the 16 is bigger than the 7. So if one side of a triangle is longer than the other, this side is longer than this side, then the angle opposite the longer side, so if I'm looking at this angle opposite the longer side, is larger than the angle opposite the shorter side. Okay, so this angle A right here is opposite of a bigger side, and angle C is opposite of a shorter side. Angle A is opening up to a 16 unit side, so it has to be a bigger angle than angle C, because angle C is only opening up to 7 units. Angle A is opening up a lot bigger. It's opening up to a 16 unit side. Therefore, angle A must be larger than angle C. It is definitely a true statement. The answer here is yes. Now, would it also work if I knew the angles in a triangle? Could I draw a triangle like this and put in, let's say, a 60-degree angle and a 50-degree angle? If that's 50 and that's 60, that's 110 right there. So that means this one's going to need to be a 70-degree angle because they have to add up to 180. So 70 degrees. Would I be able to tell right now which side is my biggest side? Here's angle A, angle B, and angle C. If I was looking at it right now, could I show for sure which side is my biggest side? And the answer is yes. Because this theorem right here shows that if you go up, the biggest side is across from the biggest angle. The smaller side is across from a smaller angle. So you could actually switch the theorem around, angle and the side, you could reverse them and say if one angle of a triangle is larger than another angle, so let's say this angle right here is larger than this angle right here, then the side opposite the larger angle is longer than the side opposite the smaller angle. It means this BC is going to be bigger than this AC because it's opening, this 60-degree angle is opening up. This is only a 50-degree angle. The biggest side right here is from the 70-degree side. So this 70-degree angle right here is going to make that right here be the longest side. So that'll definitely be longer because it's opening up to a 70-degree angle. So that would be my longest side right there. My shortest side would be across from the 50-degree angle. So right down here would definitely be my shortest side. Now, it may not look like that in this picture, but if those were the correct angles, then you would have your longest side and your shortest side. Those are the inequality and triangle theorems. There you go.